Hello, it's great to be here for the 2021 VI Grade Zero Prototype Summit. My name is Steve Rohweder, and I'm the Vice President of Technology Development for Goodyear out of Akron, Ohio. I've been with Goodyear for 35 years, and my team is responsible for the development of future product technology, including our tire modeling and virtual simulation capability. The early part of my career at Goodyear was in the area of tire vehicle dynamics and included objective testing, tire force and moment modeling, as well as vehicle simulation to aid our product development process. So you can understand the honor and pleasure I have to present this keynote on Goodyear's virtual simulation capability, specifically the work we've accomplished over the past year. Last May, Goodyear's Greg Camarado shared some insights around virtual becoming a reality for the tire industry. And today, I'd like to share a few more details on the progress we've made, how we're incorporating our driving simulator investments into the product development process at Goodyear. Goodyear's background as a leading tire company is based on developing winning products for our customers and consumers all around the world. That product development engine introduces well over 1,000 new consumer tires into the OE and replacement market each year. To manage that amount of development, we've prioritized several areas to build capability through the years. First, we have a significant capability in finite element tire modeling from our partnership with Sandia National Laboratories. Secondly, we maintain a continued focus on new product innovation and technology flow that feeds those next generation products. Third, we have a strong emphasis on lean product development principles to drive stability and efficiency into our process. And today, we're enhancing that with driving simulators to extend our leadership as a development partner for our customers' most difficult problems. You may have seen this quote from our Senior Vice President and CTO, Chris Helsel, when we announced our second dynamic simulator. In fact, we just released our corporate annual report, and on the cover is a photo of our recently installed Dim250 Simulator here in Akron, Ohio. We believe our product development engine is a competitive advantage, and the Goodyear technology leadership team is aligned to extend that position with these investments. The first Dim250 is installed at our Innovation Center in Akron, Ohio, and is being utilized for product development globally until we complete the second installation sometime next year at our Innovation Center in Luxembourg. Together, these two locations support product development globally for the Americas, Europe, Middle East, Africa, and the Asia-Pacific regions. I expect both units to be quite busy with virtual upfront engineering work before the OE request for quote, as well as driver engineer training and the future technology enhancements to our modeling for the tire and vehicle development decisions being made. As you can imagine, installing such equipment during the pandemic proved quite challenging, but the efforts of VI Grade and Goodyear personnel globally were able to make the Dim250 operational before the end of last year, all the while keeping safety and health of everyone involved as a top priority. We recorded a relatively brief but exciting time-lapse video of the installation that brings our Dim250 to life. I'd like to share that with you at this time. Please take a look. It's so much easier when compressed down in time, but again, my hat's off to the teams that work together under such difficult conditions to meet the end of year completion. Now let's take a look at some of our activities since that milestone around incorporating the equipment into our virtual development process. We use a pretty comprehensive project management approach to this integration because of the impact on physical prototyping, on our compute capacity for modeling, on engineer and driver training, as well as all the digital infrastructure to capture and distill the vast amount of data being generated from these evaluations. We've explored the simulator motion space with respect to the variety of maneuvers used in physical tire tests, both on a track VDA surface as well as on various road course facilities around the world. We're constantly enhancing and adjusting the tire models, so real-time execution in the simulator is another area of integration focus, using tools like CD Tire and Pacheco models, as well as in-house Goodyear capability. We've started a training suite for our expert drivers, giving them time in the cockpit to tune the simulator for their customer priorities and evaluation needs. Initially, this is focused on steering and handling performance with the work in Akron. We've also begun some virtual development programs with OE customers around the world, and we'll be exploring additional tire and vehicle performance aspects in the near future. So where do we see the industry going with the advantages of simulators? We expect a substantial growth of virtual development work now that we can quickly connect expert drivers to the complex physics of how we mathematically simulate the tire on a vehicle. We expect a reduction in the number of physical prototypes that will more than offset the substantial objective data collected during the virtual maneuvers and the complex detail of the tire and vehicle models. This will lead to more opportunities for big data and analytics around digitizing the driver, as well as fingerprinting the vehicle DNA, which have not been easily employed with physical testing. Finally, the rapid turnover of design decisions in the virtual world will require adjustments to how we interact with our OE customers and the collaboration of those development decisions, which today are more like weeks apart, tomorrow could be within the same day. So how do we bring this capability to impact the process sooner? It starts with evaluations of virtual vehicle models before any physical prototypes, and will support the target setting process of RFQs that we use today. Achieving the appropriate level of physics in the models that can still be executed in real time will mean balancing the hardware and software capability together as we go forward. Today, we put considerable effort into aligning our drivers with the OEMs, and that same alignment will need to be maintained in the virtual simulator world. We expect the time spent virtually assessing program targets and our product design approach will result in a higher level of maturity and success in the first physical prototype submissions and a faster convergence to the overall targets for the program. Today, we are actively working with several OEMs on virtual tire and vehicle programs before the RFQ timing. This includes exchanging models for use on our Dim250 equipment, and in some cases, joint evaluations with drivers from both parties in the simulator. We encourage our OE customers to bring their questions to the development teams ahead of sourcing and target setting to collectively explore the performance space together. So this new process involves much larger data sets and a variety of machine learning or optimization tools before the tire development kicks off. It extends the use of our current virtual capability to assess design changes before physical prototypes. It will add more complete virtual evaluations before building tires with the intent of shortening the overall development timing compared to the past. In fact, we track these iterations, both physical and virtual, on our development programs as another indicator of our lean product development methodology. As another demonstration of our progress on this capability, we pulled a video recording from an on-track tire test back in 2019 and made a comparison to the same section of track using the Dim250 late last year. This is the same driver on the back section of Virginia International Raceway coming up on turn 13. Note the similarities between the two screens, including the representation of the track surface markings and the curbing which drivers rely on for these evaluations. Take a look. That's always fun to watch, let alone comparing and analyzing all the engineering data generated between these two events. I want to thank you again for this opportunity to share our progress on virtual capability. I also want to say thank you to VI Grade for the invitation to present. I look forward to the day when these events are able to be held in person again, and I'm eager to hear the rest of the summit presentations. On behalf of Goodyear, stay safe, enjoy the conference.